Drag and drop ML is fine and all, but let's get beyond the basics and write some code. Welcome to this video on Azure Machine Learning. My name is Kevin Fiesel. I'm the proprietor of Catalexy Services, LLC, a consulting firm which specializes in work across the data platform space, especially SQL Server. So far in this series, I've shown you the nickel tour of Azure Machine Learning's automated machine learning tool and its designer UI, both of which are low-code experiences for performing machine learning. They work well enough for what they are, but they are inherently limiting in ways that writing code won't be. For that reason, I think it's time to switch over to writing some code. To do so, we have a pair of methods available to us. The first is running code in Jupyter notebooks, and the second involves executing scripts using the Azure ML SDK or command line interface. Azure Machine Learning has built-in support for Jupyter notebooks, allowing us to execute notebooks against compute instances. In case you'd like a quick reminder, compute instances are Azure virtual machines which have a series of ML tools pre-installed. We usually create one compute instance per team member, and those machines are really useful for prototyping and development. In addition to running notebooks, we can execute scripts using the Azure ML Python SDK. Now, there are actually two versions of the SDK, V1 and V2. At this point, V2 is generally available, and I would recommend using it in any new projects. Though, if you have code running the existing V1 SDK, it will still work as is. This SDK works, as you might imagine, with the Python programming language. But what if I don't want to write code in Python? Good choice, I'd say, but then people start heckling me whenever I give my opinions on Python. Nonetheless, if you're using another language, such as R, F#, C#, and even Java, you can use the Azure Command Line Interface's ML v2 extension to push the code to remote compute and execute it, assuming your remote compute instance has the right libraries installed for that language. This approach will also work for Python code, assuming you just want to use the CLI rather than a separate Python-centric SDK. That's an overview of what's available to us. Now let's hop into a demo and try out some notebook functionality in Azure ML. Here we are in the Azure Machine Learning Studio. What we will do during this demo is perform some exploratory data analysis of the Chicago parking tickets dataset. We can use the Python programming language to retrieve data from an existing Azure ML dataset and learn more about the shape of the data, including the various features available, unique values, and how closely numeric features correlate with one another. We will also look for missing values and other things which might trip up our analysis. By the time I'm done, we'll have an idea of what we need to do before we can properly train a machine learning model. Now let's make it happen. The first thing I'm going to do is navigate to the Compute tab and make sure my compute instance is turned on. As you can see, it's already on, so I can make use of it. To the right of the name, we see a column called Applications, which has some links to applications like Jupyter Lab, Jupyter, and VS Code. Selecting one of these links will take me to an app in the context of that compute instance. For example, if I select the Jupyter Lab link, it will open up a new tab with Jupyter Lab's user interface. So if you're already familiar with this style, you can use it directly. Now, alternatively, I can select the Jupyter link and see a more classical Jupyter notebook interface, allowing me to drill in and open a notebook. Note that regardless of the technique I choose, I'm still executing the same notebook against the same Jupyter installation. It's really just the UI which changes. And there's even a third interface that we can try, the Notebooks tab in Azure ML. This UI focuses more on what makes Azure ML unique. The notebook interface is separate from our compute, so if I drill into the compute drop-down list, I can see not only our running compute instance, but also a serverless Spark compute if I'm running PySpark jobs. I can also select the kernel's drop-down list and see what's available to me. We have a few different versions of Python as well as one version of R. In order to interact with Azure ML's v2 SDK, I want to make sure I'm using the SDK v2 kernel. Next up, I can create a new notebook or work with an existing one. If I want to create a new notebook using the Azure ML UI, I can select the plus icon in the Files tab and choose Create New File. This will create a new notebook and open up the notebook's interface, and you can hack away at whatever you need to do. But I'm going to show you a slightly different way to work with notebooks, one that I think makes sense in a world with source control and expectations of code permanence, and that is to use Visual Studio Code to do this work. Here I am in Visual Studio Code. One really important thing is that I have the Azure Machine Learning extension already installed. This will allow me to work from my desktop machine, but execute code against a remote Azure ML compute instance. What's nice about this arrangement is that I can easily integrate with GitHub or whatever other source control system I'm using. If you're feeling lazy and just want to use the Azure ML UI for everything, you can do that. But this is a nice habit to get into, especially if you're developing code or notebooks which you intend to check into source control and keep around for a while. Let's switch back to the Files tab in VS Code. In here, I have a notebook for Chicago parking ticket analysis. That way, you don't have to watch me typing stuff in, as fun an idea as that sounds to see me have repeated typos and have to backspace a whole lot. Now, up in the right-hand corner, I have the ability to select a kernel. Choosing this brings up a Visual Studio Code menu, letting me select how I want to run the code. I'm going to choose my Azure ML compute instances, as I want to execute this against the CS compute instance rather than locally. If I really wanted to run this locally though, I could, so long as I have a Python installation as well as the Azure ML Python SDK v2 set up. I'll choose the Python 3.10 SDK v2 kernel, and now we have our interface set up. Then, to run one of these cells, I can mouse over and select the play button for that cell. This cell is importing some namespaces in Python and also loading my workspace. The from_config method looks for a specially named file called config.json. It's usually in a folder named .azureml, like you can see here. I'm not using this particular config.json file on my compute instance, but I will make use of it in a later video. Still, if I open it up, we can see what's inside. I need 3 things in this file: a subscription ID, a resource group, and a workspace name. With these 3 items, Azure ML has enough information to know which workspace I want to use. I still need rights to access the workspace, of course, so even if you have my subscription ID and workspace details, you're still not getting in. Not even if you ask nicely. Well, maybe if you ask nicely. But anyhow, let's go back to the notebook. I mentioned clicking the play button to run a cell, but I prefer the keyboard shortcut of Shift plus Enter. I'll use that to execute this next cell as well as all subsequent ones. This cell is pulling in my Chicago parking tickets dataset, which contains 1 million rows of data. How do I know it's a million rows? Well, I can run the len function and tell you. I can also use head to give you an idea of the shape of this data. We can see that there is a variety of column types, including one date time, followed by strings and numeric values. Scrolling all the way to the right, I have a column called Payment is Outstanding, which is the label. If the value is 1, it means that a person still owes the City of Chicago money for an outstanding ticket. If the value is 0, it means that the person does not owe money any longer because they paid the ticket or a judge threw out the ticket in court. Another common task we have is to figure out the cardinality of a feature, that is, the unique set of values. We can run the unique method against a pandas data frame and get the values. We can see here that all of the values are integers, save for the last one, which is nan, or not a number. Nan can mess up certain algorithms, so we'll want to fix those. Also, I'll be really annoying and sometimes say nan, and sometimes say nan, and sometimes say not a number. We'll roll with it. But look, doing this for each column kind of sucks. Fortunately, we can use the apply function and execute a function for each column. In this case, the function I want is called inUnique, which returns the number of unique values for a given column. We can see that almost every issued date is unique, but most of the features look like they're fairly tightly constrained. 77 communities, 13 sectors, 9 sides, and so on. For issued date, we might want to break it out into component parts. Year, month, maybe day of week, maybe whether it's a weekend, that sort of thing. We could also take time of day and put it into intervals. The idea here is that with nearly unique data, we aren't going to learn a lot from the issued date feature itself unless we perform a specific time series analysis, which we're not doing here today. But we might notice patterns in blocks. For example, maybe older tickets are more likely to be paid than newer tickets, or maybe overnight tickets get paid less often than tickets issued during the middle of the day. We'd have enough data points to make these sorts of judgments rather than having one or maybe two data points for an exact date and time. The next thing we'll look at is license plates and vehicle types. There are 64 unique values for license plate, which seems a bit odd when we know that there are only 49 states.
There are only 49 stars on that flag.
I'll be deep in the cold, cold ground before I recognize Missouri.
Well, it turns out that the reason we have 64 states is that this includes out-of-country plates, especially from Canada. Also, note that Illinois dominates the listing here, as we might expect, so we could benefit from grouping the states together. By the way, the pandas option for setting max rows is something which the Azure ML UI for notebooks respects, but apparently Visual Studio Code doesn't, so we only see a few dozen results instead of the full list. As far as plate type goes, passenger vehicles dominate, followed by semi-trucks and then temporary tags. The rest of these are rare enough that we probably should just group them all together. We can also filter down to see a few rows for each value of payment is outstanding. It can be instructive sometimes to see if there's a pattern we can catch with our own eyes. We won't find anything certain with just 5 rows, of course, but there's always a chance we spot something. Now, I'm going to perform a correlation analysis, which correlates each pair of numeric features. For example, hardship index has a negative 0.87 correlation with per capita income, a positive 0.84 correlation with percent unemployed, and so on. This means that hardship index very highly correlates with several variables, and so we might want to combine or drop some of these highly correlated features. Also, looking at the bottom row, we see that payment is outstanding is a numeric feature, so we get to see how it compares to other features. Scrolling along, nothing really jumps out as highly correlated. That's not necessarily a terrible sign, but it does say we probably won't find an easy answer for modeling, as in one column determines whether payment is outstanding. Let's now add in year and month, and then rerun the correlation exercise. Looking at the payment is outstanding row, year has a negative 0.13 correlation, which is mild but reasonable considering the other variables. Month, meanwhile, is close to 0, indicating that the month of year doesn't matter much, but the year itself does. Older tickets are more likely to be paid off than newer tickets. The last thing I'll look at is whether there are any missing variables on a per column basis. Scrolling through here, we see 4 columns with missing values: tracked, police district, plate type, and license plate state. As a result of our analysis, I've got a few ideas. First, we can find and replace missing values for police district. Then, we can create a feature for year. I'll also create features for the time block of the day, such as overnight, morning, afternoon, and evening, as well as the license plate origin and the vehicle type. I'll just remove census tract, which has missing values and just overlaps a lot with ward, community, and neighborhood. I'll also remove hardship index because it ties so closely with several other interesting measures. Finally, for the rest of the string features, we will need to encode them, that is, convert them to numeric values, in order to perform a classification analysis. There's a lot of work ahead for us, but thanks to this notebook, we at least know what we need to do. This is what I consider to be a good use for notebooks in Azure ML, learning more about the data. I can take a notebook, results and all, and check it into source control. That way, I know how the data looked at the time of initial analysis, which can help future maintainers of our models understand why we made some of the decisions that we did. This notebook format also allows us to document our thought process. This makes sharing information with team members easier and can also help in training new members on a team. But notebooks are not the end-all be-all for code development in Azure ML. I like them a lot, but when it comes to automating model development, there's a better way. I'll need to do a little bit of a detour in the next video, but in the one after that, we are going to look at what that better way entails. We'll have links and show notes in the description below. And until we see each other in the next video, take care.